Welcome to the Italian Wine Podcast. This episode is brought to you by Vinitaly International Wine and Spirits Exhibition. The 54th edition of Vinitaly was held from 10 to the 13th of April. If you missed it, don't worry. Go to vinitalyplus.com for on-demand recordings of all the sessions from the exhibition. And remember to save the date. The next edition of Vinitaly will be held from the 2nd to the 5th of April 2023.
Welcome to Professore Attilio Scienza's newest book, translated and narrated by Richard Huff. This latest publication is part of the Mama Jumbo Shrimp series, entitled Mama Jumbo Shrimp Guide to Vine and Prejudice, Fake Science and the Search for the Perfect Grape. This is a great way to get a sneak peek at the book before it hits the shelves, so listen in and let the geeky knowledge seep into your ears, because we all need a little bit of Scienza.
Chapter 6. The Paleontology of the Vine. Returning to the past to understand the present. For the British naturalist Alfred Wallace, an important prerequisite for determining the region of origin of a species was the availability of fossils from the Tertiary period. Such evidence highlights the changes that have occurred on the surface of the Earth. The genus Vitis possesses this requisite, as evidenced by the extensive paleontological evidence of pre-vinifera leaf imprints found in northern Europe. They are considered sufficiently evolved in an adaptive sense, with well-studied taxonomic relationships. The origin of the vine and its biological evolution are singularly linked to two dramatic events in the history of the Earth: mass extinctions and separation of the continents. The so-called mass extinctions were catastrophic events that led to significant losses of plant and animal diversity. At least 5 major mass extinctions are known to have occurred. Those involving the vine, at least indirectly, occurred in the Permian Triassic about 250 million years ago, and the Cretaceous Paleocene about 60 million years ago. The third extinction can be attributed to a series of massive volcanic eruptions that caused a dramatic change in the Earth's climatic conditions, with an increase in carbon dioxide and ozone concentration. The fifth extinction, which saw the disappearance of the dinosaurs, occurred in the Cretaceous and was caused by the impact of a huge meteorite on the Yucatan Peninsula. The dust that arose from the impact obscured the sun, preventing the photosynthesis of plants and leading to a devastating famine for the dinosaur population. Tectonic movement during the Cretaceous triggered the phenomenon of continental drift from the fracturing of Pangaea, the giant supercontinent, which began 200 million years ago. Two great land masses, Laurasia and Gondwana, were formed, as well as the great mountain ranges of the Alps, the Andes, and the Pyrenees. The first effect of the separation of the continents was to interrupt the integrity of the Rhamnales, an order of plants to which the Viticulture family belonged. The evolutionary paths of the genera were subsequently separated, and they had to adapt to the climatic characteristics of the newly formed environments in which they found themselves, creating new taxa. North America was not separated from Greenland. On the threshold of the Tertiary, or the Cenozoic era, in the Eocene about 50 to 60 million years ago, the climate in Europe was almost tropical, with coral reefs, flora and fauna comparable to the warmest areas of the Earth in the current era. In this climatic phase, the Viticulture were represented above all by the Cissus, from which the genus Vitis has differentiated. The climatic conditions gradually became hotter and drier, pushing the vine northwards, where the increased humidity encouraged the formation of vast forests, which were more favourable to the vine because they offered structural support to the tendrils, allowing the plant to climb. The fossil remains of vines in the form of the leaf of Vitis caesarensis, found in the marl of Champagne, and in the clays of Silesia are considered the most ancient, belonging to the Eocene strata of the early Tertiary. These findings in the regions of northern Europe testify to the origin of genus Vitis from a more ancient taxon. In the middle of the Cenozoic, about 35 million years ago, the changing ocean currents, whose courses were modified by the separation of the continents, caused the climate to cool down. As a result, the flora took on different characteristics with the development of deciduous trees, indicators of a seasonal variation. By the end of this era, the features of the tropical climate had disappeared. Fossil remains testify to the presence in Greenland to various forms of Vitis, of species with leaves similar to those of the western lime and the Vitis of Alaska. In the deposits of the Laramie Formation in northeastern Colorado and in the lignite mines of Central Europe, fossil leaves identified as belonging to genus Vitis have also been found. The imprints of the vine leaves are reminiscent of Vitis riparia. The fossil remains are numerous, exceeding 300 sites. Indicative are the finds in Europe of remains of leaves and grape belonging to the genus Vitis and also to more ancient and now extinct genera. Findings made in Armenia, dating back to the Eocene, show the simultaneous presence of remains of various extinct and non-extinct species. From the Pleistocene, ancient remains of Vitis sylvestris appear in sites of Central and Northern Europe, testifying to the expansion of the species to the north in the last warm interglacial period. In central Italy and southern France, the remains are more precocious, dating back to the Pliocene, and are found in the diluvial tufts and travertines along fig and laurel leaves. The great genetic variety of the past was decimated by the Quaternary glaciations, which gradually pushed the only surviving species, Vitis vinifera, to the southernmost locations. A certain persistence of Vitis vinifera has also been proven in the interglacial periods, with a greater number of instances in the Caucasian basin and in the mountains of Asia, due to the shorter duration of the cold phases and the elevated position of the refuge sites, which are found over 2,000 meters above sea level. The leaf prints of these Viticae can be considered a transition between the American and the European Asian type of Vitis vinifera. In particular, the secondary ribs and the shape of the lamina show a clear resemblance to those of fossilized and living American vines, such as Vitis riparia and Vitis cordifolia. Vitis browni, discovered in Germany, whose remains date back to the early Miocene, has leaves very similar to Vitis labrusca. This is an important clue of genetic continuity within the Vitis genus in the Eocene before the two continents were separated by the Bering Strait. The wild forms of Vitis vinifera in Europe are therefore relics of the flora of the Tertiary and have been saved, if we can say so, from the destruction wrought by the ice, by the birds interested in their berries during the interglacials, guaranteeing continuity of the genetic flow by moving to different latitudes. The coexistence in Europe of the types of leaves belonging to the North American and Eurasian species is maintained throughout the Pliocene, only to disappear at the beginning of the Quaternary, in which only traces of Vitis vinifera are found. The origin and particular nature of these finds are an expression of the climatic characteristics of the Quaternary, the phases of expansion and retreat of the ice, and the consequent lowering and raising of the sea level. Beginning 18,000 years ago, sea levels have risen by about 120 meters. This process has dramatically affected the climate, the evolution and migration of flora, fauna, and human species. It has been the reference level for construction of the current landscape morphology and for the delimitation of the current continental boundaries, previously connected but now separated by extended waterways, such as the Beringia, which became known as the Bering Strait. Some recent finds of leaves and fossil clusters in Lycinia in the Val d'Alpone in northern Italy have reignited interest in the territory in relation to the origin of the vine. In the mid-1800s, fossil remains, leaves with berries, of a genus with an uncertain taxonomic location were found in the limestone of the Tertiary, with many morphological similarities to the vine cultivated today. Together with the imprint of the leaf, a fruiting flower cluster was also found, in the form of a stem to which some berries were attached. The cluster belonged to a genus that had disappeared during the Quaternary glaciations. This paleontological evidence, together with the remains of tropical plants such as figs, eucalyptus, and coconuts, confirm the existence of a tropical climate. Also noteworthy is the discovery of the belemnite rostrum, the bullet-shaped tail of an extinct order of squid-like mollusk. Such fossils are commonly found in the Champagne marls and have a notable stratigraphic significance for the Cretaceous. These remains, however, are very different from both those of northern Europe and those from central Italy, and curiously are similar to the morphology of the ancestral clusters, that is, of the Cissus from temperate regions such as North America. Unlike the cluster of the current Viticulture, which usually have a more or less elongated shape, the Cissus have roundish clusters, as the length of the second and third axis of the main stems are very similar to each other, and therefore give the cluster a globular shape. Furthermore, the axis of the flower bunches are much more elongated than those of a cluster of genus Vitis. These remains could perhaps represent a link between the Cissus and the Vitis in a geological phase between the Paleocene and the Eocene, about 65 to 55 million years ago, during which the continents were still connected but had just begun the process of distancing, which would lead in the Tertiary era to the current continental layout. This would have allowed the coexistence in Europe of American and Eurasian types that remained throughout the Paleocene, favoured by the exchange of plant and animal forms between Europe and North America, thanks to the presence of a Miocene continent in the area currently occupied by the northern portion of the Atlantic. To confirm the common origin of American and European vines, recent research on the phylogeny of the genus Vitis, applying the Bayesian clock dating methodology with fossil calibration on nuclear and plastid DNA sequences, proposes the centre of origin for the genus in the New World. This would suggest that the species migrated to Eurasia about 40 million years ago. The clade that contains most of both wild and cultivated Vitis vinifera features some North American species. It is hypothesized that the land bridges of the North Atlantic were the most plausible route for migration from North America to Eurasia, thus overturning the hypothesis previously formulated that saw the spread of the genus Vitis in the opposite direction. With the end of the last glaciation, the emergence of a climate similar to the current one, with 4 distinct seasons, the genus Vitis was a continuum between North Europe and America, and only the climatic changes that occurred 5.5 to 1.5 million years ago caused the fragmentation of populations by creating their genetic isolation. In fact, fossil remains of grapevines in Poland, Denmark, and the United Kingdom testify to the existence of grapevines in the Quaternary period in northern Europe during periods presumably characterized by mild winters and high summer temperatures. In the final phases of the Tertiary era, the Earth cooled cyclically, and during the last glaciations, in particular the Reese glaciation and the Worm glaciation, almost all the northern species of vine disappeared. In Europe, only one species remained, Vitis vinifera, while in North America and East Asia, the glacial survivors were more numerous. The earliest vines similar to the European vine that we know today emerged in the Pliocene, and during the glacial pulsations, The area of origin was fragmented into two glacial refugia, one Mediterranean and the other Caucasian. During the Quaternary glaciations, European vine populations were probably isolated in southern refugia in the Iberian Peninsula, in Italy, and in the Caucasus. The distribution of these populations and the modern biogeographic evidence, confirmed by the DNA analysis of the chloroplasts, suggests a subsequent recolonization during the last Pleistocene interglacials, or in the Holocene.
Thanks for listening to this episode of the Italian Wine Podcast, brought to you by Vinitaly International Wine and Spirits Exhibition, the biggest drinks trade fair in the world. Save the date, the next edition of Vinitaly will be held the 2nd through the 5th of April 2023. Remember to subscribe to Italian Wine Podcast and catch us on SoundCloud, Spotify, and wherever you get your pods. You can also find us at ItalianWinePodcast.com. Cin Cin!
Hi guys, I'm Joy Livingston and I am the producer of the Italian Wine Podcast. Thank you for listening. We are the only wine podcast that has been doing a daily show since the pandemic began. This is a labor of love and we are committed to bringing you free content every day. Of course, this takes time and effort, not to mention the cost of equipment, production, and editing. We would be grateful for your donations, suggestions, requests, and ideas. For more information on how to get in touch, go to ItalianWinePodcast.com.